that has the files in it. It's in documents.
Yes.
We don't have it.
It's in documents, yeah. I have it on this. That's the only difference. Okay, so just to make sure that you have the correct ASPI version, check on the left corner. It should be today's date, January 29th, 2026. That also the 3D looks different. Hello. Hello.
Before everybody gets started.
Okay.
Okay, it's good to hover.
Okay, good. So the first thing, let's load the data. So we, well, last year we reimagined the whole menu bar. This year we made some changes and Core updated ASPI util too. And so some of you are familiar with the, just one sec. So you are familiar with the old ASPI util. So in the 3D, if you go to ASPI post-tag utilities, you can still open it, just to let you know. It's kind of difficult to me because this is it's 150%. So let me just hide this. This percent. There you are. Okay, so you see now that everything is the same. So if you go to ASPI util or the 3D, you have the same import export, the same capability. So it's unified now. Just to let you know, but we will continue working on the 3D on Windows. So the import export, let's go to 3D data volumes. We're gonna load a volume, and then you go to convert a SegWi volume to ASPI format. So in the new import export, you see we have the ASPI default parameters, 3D volumes, 2D data lines, 2D seismic surfaces and wells. So now we have everything unified in that tab. So it's easy to follow. So let's go to this convert a SegWi to ASPI format. So now by default, the output format is going to be VDS. So ASPI still produce 4 files, the .h, that is like a text file with all the ASPI information, like the seismic information. And it used to produce this .h add, that it was the binary data set. And then the header information is the .h add, and the .h add. So all the thing is the same, but the .h add, it has been replaced with VDS. With the VDS, we can use the 3D straight out of the box. So this capability has been there for some time, like a year and a half at least. But the default was still the ASPI format, but now we changed to VDS. If you want to use the old default ASPI format, you only go to import, export, ASPI default, and then change it here. But I'm not gonna do that. And let me know if any questions. This is not part technically for the demo.
The entire backend is now operating on just PDF.
Yes. So all the binary information for the post-tag data.
Okay.
So if you go to pre-stack, it will do the ASPI.h add, but it will do it automatically. You don't have to switch. I'm gonna do this or that. Like it will handle that. We're still polishing some of the codes to handle it better. And let us know if something like okay, the VDS, yeah, but it should be backend working.
So for the pre-stack, you guys are not using VDS?
No,
And
no.
no plans to?
We plan to, but we are in this like probably we're gonna implement OpenCGI first on post-tag, so we have both capabilities. Especially because some sponsors would like to have CGI on Linux. So OpenCGI gives you the option to have it on Windows and Linux. So that might be the next step, and then we will focus on pre-stack. We are deciding, but at some point we will get there. Yeah.
There's a CGI option or?
The CGI option, there is one on Windows, but I got this note that apparently it works until the 2022 version. So I don't know if they changed something, and that's outside our capability. But OpenCGI hopefully will update that too. So that's probably the next step for the import export. Okay, so let's load the data. You have here, this is a typical visualization. I'm gonna browse. I'm gonna go to day 1. And then you have several demos. I'm gonna go to the first one, Unet for fault prediction. So I divided into the training and prediction. Let's start with the prediction first to show you some of the capabilities. And then we will go through the training steps. I don't plan to train a Unet today in 10 minutes, to be honest. But I just want to show you the steps, how to do it, so you can train your own in your office. So let's go to prediction first. Select prediction. You will have this demigrated GSV, the gray cell bathing. So I'm gonna just select that SegY, click OK. As usual, AASPI is gonna ask you for the unique project name. So I'm just gonna put AASPI _ demo. You can put test or your name, whatever you prefer. So for the SegY line header, you see that it's like, so you need to change the byte location. So by this one is using the default. The next one that we're gonna try is gonna be the more Petrel 73, 77. We will change it later. But this one, you see that the X coordinate is 181. The Y coordinate is 185. So it's right there. Yes.
The segue is on.
Yes, day one. So let me just go again. So go to day one, Unet prediction. So day one, Unet prediction, and then go to prediction. Unet for propagation prediction, then you have the migrated GSB. Okay, you click there, and then you have the AASPI. Okay, you put,
Petrel. One of the other systems.
Yeah.
That were developed before the SegY 1996 or whatever year standard came out. It was default.
Yes.
Yes, we default. We could set it to be 5.
You see there? So you can change all the defaults basically. Okay, so well, the defaults work here. I know this is fine. So I'm gonna execute SegY to AASPI. It's gonna double check the initial time and the end time and the sampling interval. That looks fine. That's the volume. So I'm gonna click yes.
And the reason for that is in the SegY header, you have to migrate your timeline. You gotta look at it and make sure F or is it kilometers,
Okay, so AASPI will provide you some of the information. Looks fine. Huh? Is in meters. Yes. So the defaults are fine this time. Both of my volumes are gonna be meters. Some of you probably are using feet. So no. Okay, so now this like the 3D, I'm gonna focus a little bit more after the final part of the demo, but you can actually go and low seismic VDS, and you see that you have this migrated GSB demo. So you click there, you open. Let me just show you. I need to go back to 100%. Just one sec. It's kind of difficult to work on 150. Let's try 100. Okay, so it loaded. I'm gonna check box here, and you see that I have the volume there. So just to show you that you can display now the volumes in 3D and QC your data. I want to show you some of the capabilities after, but just leave it there. So let's focus now in the prediction, okay? So now that the volume is loaded, I'm gonna use the artificial intelligence toolbox. And this is a deep learning capability. So I'm gonna go to deep learning. You see that I have the fault identification using CNN. We have the SAM, you will see tomorrow. I have this AI noise removal. We'll talk this afternoon. So let's talk about the CNN. So go to fault identification using CNN, and you have two options. You can apply a pre-trained model. That's what I'm gonna do now. And then in a few minutes, you're gonna go through the steps how to create your own. Okay. So now, yes.
So there's about a right arrow.
Yes. Okay, there you are.
One is artificial intelligence, drop down to deep learning. Try not to shake your hand like an old man does. Fault identification, CNN, and then still. And then
Yeah. Yes, thank you, Kurt. Thank you for noticing that. It took me 7 hours non-stop to redo this because of the cascades. So apply a pre-trained CNN fault model. So I'm gonna click there. I simplified the GUI compared to last year. Kind of more straightforward. I actually redid the whole backend, still fine-tuning some things. So first, it's asking you for the volume. There is a pre-trained model that is called Unet AASPI I finished training in October, so that's the version that I'm using right now. V1, might change it later. Still always training, always improving. But okay, I'm gonna go for the volume, browse. You have this migrated GSV. So that's pretty straightforward, just the volume. And I'm gonna use my GPU. And just notice like the GPUs are kind of slow in these computers that you're using. It will take 20 minutes to run this. Downstairs, I have a dual 3090, so it takes like 2 minutes. A unique project name AASPI Demo, and the suffix, I'm gonna put just January 29. Okay. So now I will ask you a couple questions. The first is like the overlapping window. Instead of like just, this is the pre-trained model is 128, 128, 128, just a 3D. So instead of moving just like moving like this block and then the next block, the next block, we have some overlap. So we have the first block, and we can have like overlap, overlap, overlap. So it's just smoothing the transitions. There are 3 options, 25%, 50, and 75. I try all of them. 50 is the most like a good trade-off between good results and speed. 25 results tend to be a little bit weaker, but it's faster. And 75, taking more time, more robust, but to be honest, 50% is usually a good default, but you might try it. So I put 50%. So then when you have these patches, you need to blend the results, okay? Because you're having this patch, you have the overlap. So what happened in that overlap? What do you do with the results from this volume and that volume? So there are a couple of options. The first one is just uniform. Assume that everything is equally important. That's something that you can do, but it will give you some like edges, some artifacts. And then you have a Gaussian, still testing on some more windows. So with the Gaussian, you need to approximate the Gaussian width, the sigma value, okay, the standard deviation. So still fine-tuning some of the values. One thing that I noticed is like for folds, I like to use 0.1. Very, 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 very sharp Gaussian. So it's just like very, very sharp, the weights are very focused on the first part of the Gaussian. After that, they weigh to 0 very, very fast. I noticed that with the folds, supposed to be like geology, you know, like you don't expect the fold to be like super thick following the whole volume. Expect like probably a narrow fold. Depends, of course. You have some damage zones, but yeah.
Sorry, I missed that. Larger that value.
Yes, it's gonna be a wider.
Okay.
So you will have higher weights in the overlap. So it's up to you. I still fine tuning the parameter. But if you go beyond 1, closer to 1, you start having these patches. So still fine tuning for this. Yes. So yes. These are the width of the Gaussian.
So is there any reason why you would not mention that?
No.
I mean, here's another one transparency.
Yeah.
So scale size. You say it's related to variance. That might mean more people.
Okay.
I don't know. Maybe that's just me.
Okay, I can change the parameter like this.
Specific question.
No, yeah, it's just the standard deviation for the width of the Gaussian.
Okay.
So I might put a.
There you go.
Okay.
There you go.
Okay, so then thank you for the feedback. Then the padding. So what happened now when you have a box and you're closer to the edges? What do you do with the edges? You need to do something, right? Like the volume might not fit in the 128. Maybe you just have something that like you don't have a complete brick. So you have a couple options here on AASPI. The first one is just a constant value that is going to be 0. And the second one is just a replicate. Replicate is like you get to the edge, and then whatever is in the final 32, it will replicate that information. So based on how I trained this model, because this model was trained with the synthetic data by Shimi Wu, 2019 paper, they don't have any zeros values. They don't have any pad value. Everything is like a seismic. So replicates work better here. I'm still providing options because maybe you want to do like different padding situation when you train your own. So I'm gonna keep the replicate, and then the final value is the probability. So what happened is like, you're gonna have a result, and the result is gonna be like a log its volume, but it's actually a probability. So 0 to 1, but then you have this probability volume, and usually when you have binary classification, you assume 50%. Below 50% is 0, above 50%, 1. In this case, 1 are gonna be the faults. But what happens if you want to be more robust? What happens if you want to actually 75% probability? So you have this control that, okay, above 75%, consider that a fault, below that, consider not a fault. So you can have this tool to play with the probability threshold. You can put 50, you can put 95, 80, depends on your data. So it's just about providing flexibility, okay? So that's pretty much it. The only thing that you need to do is just execute. So I did as simple as possible, the prediction, not too many parameters like last year. So just execute, let it run. It's gonna take 20 minutes. So any questions so far? Okay, so it's just reading everything. The first patch take a little bit more, a little longer because it's loading to the GPU, but after that it's gonna be a little bit faster. One thing that we can do in the meantime is like go to the training steps. So I'm gonna explain some of those things. Okay. Any questions so far? Is it running? Good.
So we need one or two hours here. We don't have.
No, but
Yeah, now it's like.
We have more coffee coming in just a minute, just in case anybody was thinking you're gonna grab it like right now. I'm sorry. It'll be up soon.
Does David have your fancy mouse?
I'm going to put like if he's okay.
Yeah, hey, David.
Can
Fancy mouse on your machine?
can I put the like the
Yeah.
color thing?
Make the cursor bigger.
Yeah.
I would need that.
Can I put the power choice on? Like it's going to like color, make the color.
Yeah, just one second.
Your processing is stopped. I get.
I don't know yet. It's amazing, not them. That's very interesting.
This side or this side? Just check both.
Okay. I don't think so.
So this is for the,
Oh, yeah.
yeah.
Thank you.
These,
Yes.
I already put my fingers all over it. Fingers. Oh.
Look ahead, Corey's over there trying to read ahead.
I know.
You know, fast.
Something for me, I don't know. I don't know. Check. Like that, you know how it is.
I saw him with that, yeah.
No, it goes, one of these? Yeah.
Okay, let's continue real quick with the. Let's begin with the training, so the capabilities. Now we can talk about other things in the meantime. Just waiting the 20 minutes. So is it running for everyone now? Good. Okay. So let's continue. So now we'll go through the steps how to train Unet. So you go again to the artificial intelligence toolbox, the deep learning, fault identification, and then apply create a custom model. Okay, so I'm gonna leave it there. We're gonna discuss the steps. So the first step is to import your surfaces here, and you have your interpretation package. You have some faults picked. Okay, so you can export that. There are several formats. We discussed that. So you have your faults. You import it to AASPI. So that's the first step. Then the second step is create this binary fault label volume. So you have your seismic volume. Okay, you have your faults. So with the faults and the volume, it will provide a volume that is zeros and ones. Zeros for anything that is non-fault, one where your faults are located. Okay, so you have that volume. After that, it will take both volumes and create the patches. So you can create like 128, 120, 128, 64, 64, 64. You can actually change it. You can have 64, 64, 512. Like it's not fixed to the same parameter. You can change it in the direction of the inline crossline of time or how many samples you want to process. Just caution is like if you go time with 512, because I have tested, you need a good GPU to train your models. Okay, but I assume that you have good GPUs. You need a lot of RAM. So, and then we're gonna go through, yes. Yeah.
You might have 5 years. And 12 outdoor so if you're doing 128 by 128 by 128, you determine then your analysis is going to be pretty flat. And to be so if you think the fault can go any orientation, you don't balance that out.
Yeah. So yeah, no, it will run. The limitation is RAM. So it's super easy to fit that 24 gigabyte RAM with just 120, 120, 120, 512. With 2 batch size 4, it fits already. So yeah.
Is whole backend still built on VDS?
Yes, yes. So the only thing right now that I haven't finished is like all the input it reads, but the Python part is gonna output in ASCII format.
Okay.
I'm still working on that part to hopefully in the next month I will have it ready. It's not that straightforward to write the Python for BDS, but it will be there to output BDS automatically in Python. Like I would say 98 or 95% of all the algorithms already provide BDS as output. If you run similarity deep, everything's gonna be BDS, but the Python codes still need that plugin there. I'm working on that. So, and then you have the training and the prediction. Okay, the prediction is what we just did, but you're gonna predict using your own model that you created. So let's go for the first step. Let's do the false to ASCII format, okay? So I'm gonna click in step 1. It's gonna open that window. Okay. So first is ask you about the seismic, like what seismic are you using? So I'm gonna browse. I'm gonna look for that demigrated GSV demo, the actual amplitude volume. I'm gonna click OK. Okay, it's giving you some units. Worry about that. Then I'm gonna load my surfaces and we will talk about this, okay? So I'm gonna go and load my surfaces. You can see there. I'm gonna browse. I'm gonna go to day 1. Unet. So that's the first demo. Then I'm gonna go to training. And you see that I have these 3 folds, Cora 1, Cora 2, Cora fold 1, Cora fold 2, and Cora fold 3. So I'm gonna select these 3. Are you all there? You can click OK if you're there. Okay. I click OK in the meantime. So you see that I have now the volume, I have my folds. You see this option of constant. This is because it can give you a confidence. Right now, it's 1 by default. But imagine that you have your surface, and when you pick a surface, like you pick a fold or you pick a horizon, but let's talk about a fold. When you pick a fold, yeah.
Yeah.
Oh, yeah, the brown one, then go to day 1. Maybe then go to prediction trains. Okay, so when you pick a fault, you might have more confidence in one area than other, correct? Imagine that you're picking district faults. So you see the normal fault, really nice sharp discontinuity, you pick that, so you probably 1% confidence, correct? Like 100%, sorry. So you are very confident there, but as you go deeper and deeper in your seismic and you move to that district fault, that's more open to interpretation, correct? Like that part of the district fault. Maybe I pick something, maybe you pick something else. Well, hopefully it's closer, okay? But you see, you have that part of like, it's more open to interpretation. So you can assign a confidence. That's the next step that we are thinking. Like you can assign 1, 1, 1, and maybe here 0.5, and maybe here closer to 0.25. And with that confidence, we want to input that as part of the AI, but it's not there yet. So I'm just telling you what is the next step. Right now, it's assuming that you are very, very confident in your interpretation. So yes. Yes.
One way by to horizon, you know, here on the scale horizon, I see not the confidence flow, if we in the same scale, we have a chart boundary. How to design that using those.
Yeah, how do you pick the confidence? So that's part of the limitation. Like you're gonna go and re-pick on AASPI the fault or the horizon. So. Okay, so we have the surfaces. So I'm gonna check these surfaces are, you can see like the horizon file. I'm gonna go to the training. You have to do this. I'm just going to show you. Okay, so you can open, and you see that I'm using this one in particular, Earth Vision. So the Earth Vision has some header information, and then the location in X, Y, and the time. So do things like AASPI detects automatically when it's Earth Vision is the first option. So you see this Earth Vision, you have the inline crossline interpolated. So we will do that in another example to show you how to do it. And we also have this, imagine that you have any information but the X, Y, and Z. You can even load the surface with that. So it's up to you what format do you have? We want to give you flexibility. Some of you use Earth Vision, some other Charisma or Kingdom format. So maybe you don't have any format, it's just XYZ in a text file. You can still do it. So Kurt was reworking this a lot. I know he had a lot of fun with this. So I'm gonna select Earth Vision because these folds are Earth Vision. So the input type is a list. That's what I'm doing. You can also select like a folder. Mind you have all your folds in a folder. You can select, okay, load all that folds automatically. Then the vertical units, I know these are milliseconds. So I'm gonna click again milliseconds. A little bug there with the undefined. We'll fix it later. And then the output units should be second because my seismic is in seconds. So you see my input horizons are in milliseconds, my output are in seconds. I'm just redoing that. The unique project name is AASPI Demo, the suffix, I'm gonna put the date, okay? All good?
So the input ones are the surface.
For what?
For the input.
Yes, so the input seismic volume is the seismic.
No, I mean, I'm asking the fault.
Oh,
surface
yes. It's the fault that you pick. So imagine that you are in interpretation package, you have your faults and you export that. That will be the input there. That surface. The thing is,
It's generated from multiple lines or multiple X. It's like, I'm asking, is the 3D or 2D?
it's a 3D.
3D.
Yes. So right now the unit they're gonna train is 3D. If like all the designs, you can design it in 2D. I can add that. It shouldn't take me too much to have a 2D unit and then you have a 2D because all these steps are gonna be the same for 3D and 2D. The only change is when you extract the samples and you can actually do it 2D, but the unit is coded for a 3D. So that's something that I can add actually. Yeah.
So basically, you'll have like a sparse, vertex section implementation for the 40 sticks.
Yes, I will show you the result with the full volume. I will show you that. So
And then put the 40 sticks and you guys, this code will interpolate the surface from the 40 sticks.
yeah, but the thing is like if you export it as a Earth Vision of an interpolated format, it's already interpolating the software. If you have just the peaks of the fault, that's something that we need to add in AASPI. Like, do you want to do the interpolation of AASPI so it creates like the surface for you? So right now it's assuming that at least for the faults, you are assuming that you have the surface already interpolated.
Oh, so you mean we need it? Like before I put it here, I need a fault surface.
Yes.
Interpolated.
Yes. But one thing that I want to do is like add the capability to do it on AASPI, but it's not there yet. Okay.
I see that you can import surfaces for the output volumes. Are they just volumes, or can you also output surfaces from the actual machine learning classification?
No, it's gonna output the volume. That's the next step that I have been thinking, but yeah, it's not that straightforward, but I have some ideas with that we can discuss. Yeah, so I'm gonna execute the surface import. Just telling me that because the input are milliseconds and the output is seconds, it's just gonna multiply by 0.001. Makes sense. So I'm gonna click OK. Let it run. Sure, it's super fast. You already finished. So now let's check the faults. So now you see in the 3D, I'm gonna merge a little bit both. Okay, so you have these tabs. Before in the old 3D, you have only seismic. So now you have a horizons and fault tab. Okay, so I'm gonna go to the fault. You're gonna click load a fault. But there is a little bug in the interface, so shouldn't be a difficult fix. So just double click, okay? Click again milliseconds and click seconds. It changes like the user interface, but it's not changing the back end. The back end is still unlimited. It's just one line that we need to fix. But just double check and it will get rid of the unlimited undefined error, okay? So let's go to the 3D. if you go to the fault tab,
I have that bug a little bit too. Double look at this one.
yeah, it's a good thing. So,
Did everybody get through that part okay? We still have one that's waiting.
I haven't get to that one. Okay. Do you have the faults, Iran?
Is anybody still?
Okay, I will show you that. So let's go to fault, low fault in the 3D. So you see that you have now seismic, horizon, and fault. So you can actually go and load a fault. And you have this folder now called AASPI time surface in seconds. So you double click there and you have your surfaces, surface, Cora, fault 1, fault 2, and fault 3. So one thing is like AASPI assumes that horizons and faults are surfaces. So you can actually, with the same GUI, you can actually load horizons too. So it's just a surface. I'm gonna select all of these 3. I'm gonna click open. So it just loaded here. I like when things don't work.
No.
Just go there. Okay, that's interesting. Why? Oh, I see. Okay. My bad. So something I need to. So let's remove the seismic first. I know what happened. So I'm gonna go to seismic, then you remove the selected seismic. Things like when I was plotting GSB, so I was plotting glass self basin. So you already assumed that we are in glass self basin and the faults that I'm loading are Cora, so it's not gonna match. So I need to put a parameter there. So I'm gonna go low and seismic. Okay, let's do that. Oh, I see. Okay, my bad. My bad. Okay. I did a little mistake. So the faults are in Cora, but the volume was GSB, so it didn't work. So we need to load Cora. Okay, so let's go through the steps. So first you go and browse. Let's load Cora. So you go to day 1, Unet. Gonna go to training, and then you have Cora. So I didn't have faults for GSB. Okay. So I'm gonna load Cora, similar to what we load in GSB. So you go to import, export, 3D, convert a ZY volume to ASPI format, okay? And then that will open the window that you load the seismic. You just go there and you have it. So I'm gonna select Cora. So how do you select Cora? Unet for fault prediction, training, and then you have demigrated Cora 3D, okay? Okay, you click OK. The demo, Cora 3D. Oh, I forgot that we changed seismic.
We need to unload, we need to remove the faults and reload the faults after we load. Cora.
Yes.
Yeah.
Yeah, something I need Okay, so for Cora, you see that the coordinates are a little bit different. Now it's using the typical Petret format. So it's the 73, 77, 5, and 21. So we will need to change that. For the X coordinate, it's gonna be 73 that you have there. For the Y coordinate, it's gonna be 77. There. For the inline, it's gonna be 5. And then for the CDP, it's gonna be 21. Have it there. So just changing the coordinates. Sometimes if you are familiar with loading seismic, usually that's the deal. Then I know that it's in meters, it's in New Zealand, vertical unit is seconds, so I'm gonna just execute. I'm gonna load that volume, okay? So it's loading. Yeah, forgot that we're training with Cora. Okay, finish training. So it's very similar. You go to low seismic, and now you have 2 volumes. So you select Cora 3D. You open, and there you have. Okay. So now that we have the correct seismic, let's do the steps. So we go to AI, deep learning, call, create custom. So I'm gonna stop there, give you some time to go back to the steps. Reloading the seismic.
Oh, we have to regenerate the fault
Yes,
surfaces again
yes.
too? Yeah.
Because the faults were null values. It was like
Yeah.
predicting Cora with the GSB.
Got it.
Yeah, so I actually I'm gonna put some parameters in the 3D to check that before loading, and also in the surface. If it's everything null value, don't give anything. That's good. So I'm gonna convert the AASPI surface again. So it's the step 1. Now I select the correct volume. That is gonna be Cora. Okay, over there. And then I'm gonna go to browse, similar to the previous steps. But I'm gonna go to day 1, Unet, training, and then I'm gonna select the faults again. Okay. So same, the input surfaces are in milliseconds, the outputs are seconds. So just double check. Okay. So I'm gonna load the surfaces. So, okay. Yes. So if you haven't loaded the faults again, raise your hand, please. Okay, so let's do that. So go to the learning, fault, create a custom CNN, and then you do the step 1, okay? The fault surfaces to AASPI. So then my bad was like I selected GSB, but it's actually Cora. Forgot that we're training with Cora. So just click OK. And then the rest is gonna be the same. You're gonna put milliseconds as the input units. You're gonna select seconds as the output because the seismic is in seconds. I'm gonna put a suffix here. I'm gonna put Cora, so I remember. And then in the browse, I'm gonna go to day 1, Unet for prediction, training, and then you have your 3 faults there. And then you click OK. So it's the same steps than before, but now with the correct volume. Yeah, we show you that. So just want everyone to be in the same page. So you execute, and it will load again. Okay. Okay, it's because there is Yeah, because it changes the use of the Facebook back end, it's also changing the connection of the.
We're getting in the log file.
The what?
Getting there in the log file, but I need to purge.
It's normal.
Okay, we're good.
Yeah.
So. Okay, good. So with the faults. Good, okay, so I think we have the faults, so there are a couple of things to see the faults. The first one is like now you can go to fault. And you can load the fault. You have the AASPI time surfaces. You just select click. Oh, come on. No, what happened? Yeah, I know a little trick. Let's do horizons. I mess up. Okay, I'm gonna show you that. I know how to fix it, but it's okay. It was my mistake because I mix the volumes. So to see the volume, the seismic surfaces, I will show you the 3D in a few seconds, okay? So go to the 2D. You can still display the surfaces in 2D. So you go to visualization, single volume display tools, and then you have single volume 2D display. So this is to display in 2D a seismic volume, but you can also display a horizon. So when you click single volume to the display, you have the ASPI format. I can browse, I can look for that surface. So for example, Cora Fold 1. Just click. And then, yeah, I know what happened. Okay, good. So you say you can see the fault. So to use a 3D, let's fix it right now. Is on the ASPI time surfaces in seconds. And then you have it there. It's because I loaded. So one thing is like for the 3D, because I know what happened, but you can go to visualization, single volume, okay? And let's go to single volume 3D display. So these 3D displays, open another 3D. So you can open multiple 3Ds if you want. So now that I have the correct 3D, like after not messing up with the volumes. So I'm gonna load the seismic. I'm gonna select Cora. It's loaded. And then I'm gonna go to the faults. I show you, let me see if it works. Okay, yeah. Okay, so what happened is like, because I mix, I'm gonna put some control there. Because I mix the volumes, now it's giving me an error with the faults. Things happen. So to fix it, if you're having the same error than me, so go to visualization, single volume, and you can have single volume 3D display. So that open multiple 3D. You can open multiple of them, and maybe you have one for Cora, one for GSB. You can do that. So with a new 3D, and you might ask, okay, David, how I know that it's a new 3D? Is because the 3D plot doesn't have the menu bar. You see, you don't have it. You don't need a menu bar for another tab. So it's not the main window. So now you go to seismic. I load the Cora demo, the correct volume. And now I go to faults and I load the correct faults. Okay, now this should match. Now I need a left demo trail, so they know how to put more control. Yeah. It's working? Okay. So one thing is like for the 3D, we don't have an XY file, you might ask. It's like we don't have an XYZ system here, the coordinate reference system that some software use. We don't have that on ASPI, okay? So what ASPI is doing is like you have a volume and it computes everything to 0 origin. So you can have like, depending on the number of samples that you have in time, X and Y, it moves everything to 0. What happened is like, after you have that, it's just an array, okay? So when I have the Cora, the seismic, the GSB, the size is different than the one in Cora. So you have this mismatch in the array. That's what happened. So what I'm gonna do is just put a couple controls so you cannot mix volumes, okay? Or mix coordinates somehow. I will think about it. But that's the thing, like we don't have a X, Y, Z. So I am usually when you have AASPI, you have the same like multiple attributes, but the same survey here. I'm using Cora and GSB that are completely different projects, let's say. But I didn't have any training data for GSB. So I actually want to show you how to train a neural network. So now with the 3D, yeah.
It's something anyone do in front of you, get back to your main. So we have been there. Oh, yeah, for that kind of user. Yeah, with the That's been free so much. Just gonna be janky waiting. The real way you should have this. Looking at them. Yeah. That shows that it's a lot of problems, right?
We did get more coffee if anybody was waiting for coffee.
Okay. Okay. Okay, so now let's. Hello. Yes, I'm gonna show. Okay, so couple things. Sorry for the mess up with the seismics. So now let's show you really quick how do you continue with the steps. Okay, so we have the surfaces. You have the seismic with the surfaces. Now let's generate the binary volume. Okay, so with the binary volume, as I said, it's gonna locate those faults, and where the faults are located are gonna be 1, and the rest gonna be 0. So when you input the surface directory, it's gonna ask you where are the faults. So that's when I hear AASPI time surfaces in seconds. Okay. So I'm gonna click OK. I'm just telling you the faults are there. That we okay. That we already loaded. Yes. So yeah. So it's a step 2. Okay. So that's the generate. So it's gonna ask you for the folder where the faults are. So if you browse, you click in AASPI demos, and it's this AASPI time surfaces in seconds. That's where the faults are. You click OK. And then the input AASPI format is Cora, the one that we loaded. So I'm gonna look for that demigrated Cora 3D. Then usually AASPI asks you this. I'm gonna put AASPI demo in January. Okay, with the brush parameters, so there are several options. One is like, I'm gonna use constant right now. Constant is like, yes, it's gonna be 0s and 1s. That's it. Where the faults are, it's gonna be 1. Where the faults are not present, it's gonna be 0. But you have a couple options here to have some sort of probability, okay? So you can select the square of the distance, the L1 distance, Gaussian, and rise cosine. So all of these are closer to the faults are gonna be 1s. Moving away from the faults are gonna decrease the probability. So you go from 1 to a range in probabilities towards 0. So it gives you some sort of confidence, like maybe center to the faults are gonna be closer to faults. Moving away from that, maybe it's like, okay, these are a little bit of damaged zones, especially the faults are at peak, so you can assume that probability. You can do it, and the Unet, it will know how to handle this appropriately if you're using 0s or 1, or if you're using probabilities, okay? Yes.
Here, if you're like not proud of the fault, you don't want to bias your brain to take your unsure picks as ground. And say, it's kind of sort of here. And allow it to slip left and right, up and down. Whereas if you do the narrow one, it's kind of forces you to say, okay, I'm real proud of this.
So, yeah.
So it's not a true binary volume in the back, and then it's actually a gradient volume from
Yeah.
0 to 1.
Yes, if you go from Gaussian or the L1 distance, yes. If you go constant, it's gonna be a 0-1. It's gonna be a binary. Yeah, I'm gonna do that. I'm going to show you something. So, constant, execute. Okay. So now in the working 3D, you can go there. Then you can actually load a seismic. So you see that you have this fault labeled AASPI Demo VDS. So I'm gonna load that. Just click OK. And you have it there. It's just like what happened is because everything is black and white. So in the panel, you can change to white. You have the folder. So let me show you a really quick. Yeah.
For those that with machine learning, just find the word label.
Label is just like the target. It's like label is a discrete property. Okay. So you in machine learning, you can have regression and classification. Regression is when you want to predict a continuous property. Imagine porosity ranging from 0.1 to 0.4. So you're predicting that. Classification is you have a target. In this case, it's a discrete target. So you can either classify like this is shale, this is sand, this is a limestone. But how do you put these words in the machine? So you assign a value, a discrete value, 0, 1, 2. So that's the machine. If it predicts 0, it's predicting sand. If it predicts 0, if it predicts 1, it's predicting sand. If it's predicting 0, it's gonna predict shale. If it's predicting 2, it's a limestone. So you put these discrete properties. That's what we're doing here. This binary classification is binary because it's either 1 or 0. 0 is non-fault, 1 is a fault. Okay. So with the 3D, you can change some of these things and some of the capabilities. So for example, if you double click on the name of the seismic, you see that you have the color bar. So you can change the color bar. You can choose here the color bar. For example, let's do the black, gray, white. Will change automatically. You can change the minimum and maximum. So here I'm gonna put 25,000 to minus 25 to 25. So we'll change on the fly. You can display the color bar, you can reverse the color bar, and you can move with the volume. So you can click like old school PHAs, I suppose. And then you can also play and do a little movie. So these are capabilities that continue improving with that. So you can do that with the 3D. With the fold labels, you have it there. I'm gonna double click. I'm gonna show the color bar. So what I'm gonna do is like reverse the color bar. So it looks a little bit nicer. So zeros are gonna be white, ones are gonna be black. And you see that it's matching the position of the folds, okay? So that's a way that I can QC a little bit like the positions with my folds. The fold label is actually having the correct position with the folds. I can move in my CDPs, for example, I can click here in some CDPs and I see the folds there. So it's just a little bit more QC.
Can you turn the full surface off?
Yes, so you can here fold. Just uncheck that. Then you have the fold label there. And you can turn it on. So a couple things more with the 3D now that we're here. So you can change the vertical exaggeration, as you see, depending on what you need to interpret. You can change the panel colors. And you can have multiple windows, as you can see there, that are completely independent. So for example, here, I want just to analyze the seismic with fold 1. And in the other panel, I still have my labels with my other folds, okay? So you can have multiple windows. Yes.
Visualization software that virtual and then service directory between VTK, virtual. That one. And you want to double work something out. The things that are I need to load it outside. Yes. Yeah, so the output is.
Okay. So a couple things. So the way that the 3D, I had to redo it from scratch, basically. So now it's more modular than before. If you have access to a source code, you can check it out. But now that it's more modular, it's gonna be easier to add more data. So I have a prototype with well data. Adding microseismic data like points. It's gonna be super easy now because I redo it to be modular, as I said. With the panels, you have the capability of 1,000 panels. So good luck if your computer can handle 1,000 panels with RAM, but you have the option to have 1,000 panels. And you can remove them. So for example, here I just can click and remove the current panel. So I'm still working a little bit with the interface. Couple things that I noticed today with controls. But yeah, just want to give you a good tool to QC the data, and then based on the results, you can export it to the interpretation package. The idea here is not for AASPI to replace your interpretation package. I'm not planning to have a 3D to compete with other softwares, to be honest. We are not a software company. But it's just for more QC for all of you before going to your interpretation package, okay? So because a little bit of time, so I wasn't expecting the thing with the seismic. So let's go to the full identification. So I'm gonna explain a little bit what's happening. We are not gonna train it because we don't have, even with the full demo, we don't have time to train a field unit right now, okay? But then with the extract CNN, so with extract CNA, it's like, remember, we have the seismic and we have the fault labels. We have the zeros and ones, correct? So those are my two inputs, the amplitude. Don't worry too much if you cannot follow all the steps. So just, I'm gonna show you a little bit the background. The documentation is gonna be there and you can send me emails too. So you see that I'm selecting, again, remember never mix two volumes in the same demo. Okay, so you have Cora and you have my full labels Cora, okay? I'm gonna put here NRE 29 suffix usual. So what happened now is it's gonna create these little batches, okay? So you see that the default is 128, 128, 128, and the overlap, there is no overlap. It's moving exactly 128, 128, 128, and then another patch, another patch, another patch. But you can play with that. So let's, for example, assume that in time, I actually want 64 samples. In CDP, I actually 64. So you can do it for the whole volume. You can crop the volume here. You can put like a small volume. I'm gonna use the full volume right now. So, and this is the overlap. So I'm assuming right now that I'm gonna create a 64, 64, 64 volume. And the overlap, I'm gonna keep it every 64. So what happens if you have 64 and I put here 32, 32, 32? That's a 50% overlap. So I have a 64, 64, 64. Then it's gonna move 32 samples. So you see that I have an overlap, overlap, overlap. So I'm gonna have more patches in all 3 dimensions. Yeah, these are 3D patches. So you might ask, why do sometimes you need overlap? So one thing that if you're not expert in AI is like deep learning needs a lot of data, like a lot. So if you don't have too much data, sometimes you can augment the data using these overlaps, but you have to be careful, okay? Like using like a 75% overlap, you might have redundant data, but you can play with a 25%, 50%. So these are kind of data augmentation. Overlaps are data augmentation. Rotating the seismic is data augmentation. The rotation needs to make sense because if you do this kind, imagine that you have this. If you do left and right, makes sense. If you do up or down, maybe that's not the best strategy because the audio channel looks different, okay? So think about the rotations. Just to let you know. So that's a way to increase the amount of data that you have. So I'm gonna extract right now, gonna run. It's working here, it's just extracting all these patches. Okay. Yes, so I'm gonna show you that. So it's right now it's the amplitude, so it's creating the amplitude patches and then the labels, the zeros and ones with the faults. And then it's moving it to a folder later on. So you see that I have 900, I think close to 900 patches because of the 64. And then the next step is this CNN fault training. So as I said, I'm not gonna fully train it, but how it works. So you go to your training data. I just extracted my patches, correct? So it's asking for this seismic directory. I'm gonna browse. I'm gonna have these little CNN 3D samples AASPI demo. So that's are the patches. And if I click the plus, I have the amplitudes, I have labels, you see? So my seismic is gonna be the amplitude. And I click OK. A little trick is like you can copy paste this. You can browse I give you the labels, it's gonna be faster. So you have the amplitudes and you have your labels, okay? So that's my training data. For the validation, you have two options. You can split, so you can use, for example, here from my training data, use 90% for training and 10% for validation. Or maybe you have your own validation data that you extracted. Imagine that you have your full volume, you select this crop version of the volume for training, and you select another crop version for validation. So you have two folders, the CNN 3D sample for training and the validation, and then you select different folders. So you can do that too. Right now, to keep it simple, I'm gonna use just 10% for the model. So there are a lot of parameters for the model. So the model is a Unet. If you are not familiar with a Unet, it's this U-shaped architecture. So the way that it works is you have your input in a size, in a, this 164, 64, 64. I will compress that to maybe 32, 32, 32, 66, 66, 16, 16, but it's not exactly 16, 16, but it's just compressing until you get to a bottleneck that is very compressed. And then it will try to go to that compressed space to reconstruct based on the labels. So it will give you this patch, this volume in the labels. So it's just mapping the amplitudes to the labels. That's what the Unet is doing. So what parameters you need to design for the Unet? You need to design how many layers you want to do, how many layers in between. You have this one, you want to go one layer, you have to go 2 layers, 3 layers onto the bottleneck. So here the default is 4. I'm gonna just put 1 because my 4 GB RAM GPU cannot do better than that. With the one downstairs, I was able to push it to 4 layers, but limitation here is the amount of RAM that you have in your GPU, okay? So now the filters, how the filters work. So you can see the filters in AI, in deep learning is like, imagine you have your amplitude, okay? So the filter is like, what happens if I look for all the perpendicular edges? What happens if I look for all the horizontal edges? 45, 75. So when you compute similarity, sometimes you're looking for this. You're looking for the 45 degrees, the 20 degrees. What the AI is doing is just creating its own filters. You are just training to create its own filters. So maybe what happening here is like the Unet in the first layer is analyzing these small scale features like, okay, this edge here, this vertical edge, the horizontal edge, all these edges. And in the lower dimension, just putting these together and reconstructing, okay? But this is the amount of filters. How many filters, how many edges, how many parameters, how many perspectives, let's say, you want the neural network to analyze. For the machine, I'm gonna use 16. The defaults for the Unet that you're running is 3, 32, 3 layers, 32, and other parameters. I can show it to you. So the parameters here is dropout. I cannot explain all AI in 10 minutes, to be honest, but dropout is like, sometimes you have this overfitting. Overfitting means that the neural network is like learning the training data so well, like it's just like, imagine that you are learning a paragraph with quotes, commas, semicolon, everything, all the details, but then you don't know how to extrapolate outside that. So you want to avoid that overfitting. Sometimes one strategy, the two main is like you either have more data, usually it's not that straightforward, correct? And the other one is this dropout. Dropout is like the neural network have all these parameters and maybe you randomly assign all the parameters are 0 to make the machine a little bit smaller. So it's just changing the size a little bit every time to create a smaller neural network to avoid overfitting. Okay, that's it. I'm gonna keep it off by default. Number of epochs, how many times it will see the training data. So right now I'm just gonna do 1. But you can do more. Is this not a limitation using 1? It's just the computer, okay, and time. You can do whatever you need for your interpretation, okay? The batch size is like how many at a time it will process. So this is one of the main limitations in the RAM. First is the size of the neural network. If it's too big, maybe it doesn't fit in the RAM. And the other one is how many of these patches you want to process at a time. And that's the main limitation. Even with 24 GB RAM, I was able to just fit 2, sometimes 4, depending on the trade-off between the size of the architecture and the number of samples. Here, definitely 1 is more than enough. It will these parameters will fit basically my 4 GB RAM. Then the learning rate. So you see that the learning rate is how fast, let's say, it's gonna train that model. It's gonna do the steps to try to improve the model. Okay. So there are a couple of things. You can fix a learning rate. You can use the same learning rates in all the epochs, or you can have a scheduler. So the scheduler is, I'm gonna say yes. So what it's doing is like, first it's increasing, is starting a minimum learning rate. of 0.00001, and then it's linearly increasing to the maximum, and then it's decreasing with a cosine until the minimum. So what is happening is like it has some warm-ups, because in the initial predictions, because everything is random, it can give you like weird spikes. So the warm-ups are very, very minimal, minimum steps to stabilize the neural network. It will increase to the maximum. And then when you get, imagine that you can see as a valley, okay? So you are here in the valley. This is the minimum, this is the target. So you're here. So you are having this, first you're having some small steps to stabilize. Then after stabilize, you have smaller, bigger steps, but then as you move to more epochs, more training, it's just decreasing back to 0.1. So if you plot that, this is what is happening. This is the 1.5 going up linearly in these iteration steps to 1.84, because that's my minimum and maximum, and then it's just decreasing back like that to a number of epochs. See? So it's just that. So when you're closer to the minimum, you don't need big steps, because if you do a big step, imagine that this can happen. If you take big steps, you can go away from the minimum and then just destroy your learning, okay? So, and finally, you can, well, compute the phases weights. So this is important because what happened with faults is like you have more zeros than ones, correct? Usually you don't have as many faults as the rest. So you need to balance that. If you don't balance that, the neural network will be able, really good to predict zeros, but you don't care, but you care about the ones. So what this is doing in this particular example is like, okay, it's weighting how many proportion you have from the ones to the zeros, so you can adjust properly and train better, okay? You can perform data augmentation. The data augmentation internally is doing all this shift. It's not doing this, it's doing the left and right, the rotation in the CDP axis, all these make sense rotations, okay? To augment the data. And then finally, you can save a little bit of parameters. Just save every 5 epochs, early stopping, don't worry too much about that. So one thing is like, imagine that you have your own synthetic data. So this is something that can happen, okay? You can have your own volumes, maybe you have in another software that these are these files with a 3D array. So you can actually, instead of using the AASPI format, you can just click synthetic data, and then the output format needs to be a .dat file, DAT data format. And then the shape is gonna be the lines, CDPs, and the number of samples in time. That's the shape that you need. That's the only condition. But you can have your own synthetic data and train your own neural network with your own synthetic data using AASPI. You don't have to go through the whole AASPI format if you don't want. And finally, definitely use GPU and train, okay? As I said, cost time, I'm not gonna train it, can run it, suppose. It will take a few minutes, even for this computer, even with a 1 epoch, it will take a few minutes. But then after that, we'll just give you this model, and then you go to the prediction. Let me show you. And then in the prediction, it's just similar, but instead of using the pre-train, you only need to use your selected custom, browse, and it will update everything to your own model, okay? And then you just use your own model. Any questions? Yeah.
That's you fine tuning the existing model.
Yes. So here, imagine that you have your model trained. That's a good question. So if you have your model trained here, in the model, you can continue training. So you select the pre-train, the model that is trained for 20 epochs, and then you can fine tune a little bit. For fine tuning, assuming that you're not doing transfer learning, you're not doing this, you're still predicting faults, correct? So for fine tuning, usually when fine tuning is like you have your train model, okay? I imagine that you're training your model in these 3-4 different volumes that you have before. Now you have a new volume, and you want to fine tune a little bit. Maybe you have some faults. You create your own training data, so you can take the pre-trained model, get this data, and just update a little bit the weights to be able to also perform this. So there are a couple of things that actually, I'm not gonna bore you with all these AI things, but it is something called catastrophic forgetting. When you do fine tuning and you train new data, sometimes the machines tend to forget the old stuff that learned, And this is something that is a big deal in AI, okay? And people are working to update this, especially with these new chatbots, architectures, and AGI, all these things. So to work with the catastrophe for getting. So the only thing that if you're gonna continue training, it's like my recommendation, use a smaller learning rate. Okay. Usually in fine tuning, you use a smaller learning rate because it's like don't forget absolutely all the weights. Just update a little bit, smaller steps with the new data to keep everything working. Okay. You can do that. Yeah.
So, David, mentioned amplitude.
Yeah.
It's definitely not limited to importing amplitude.
Oh, no.
So clearly, yeah, you might want to do some structural and filtering stuff, or maybe you find a certain type of fault shows up better at the 20 to 60 hertz range, so you can do a data test filter with it. Or maybe your impedance inversion volume shows a fault a little better. So that's where your creativity comes in, as to which input volume is going to prejudice the system to get the result.
One thing based on that, I've been training a little Unet for electric faults because they tend to be a little bit difficult in the deeper part of the seismic. And using just the amplitude is not great. So this F1, the F1 score for this machine, the pre-train is 81%. That's very, very good. But for the electric, I haven't been able to push it beyond 60. So my next step is to consider multiple attributes. So I'm gonna consider the amplitudes, but maybe aberrancy, coherence. So that these features might help the machine also. So that's part of the research. If everything goes well, I'm gonna add it to AASPI so you have it.
Have you considered multi-channel trading, like, is that what you just mentioned?
Yes. So what happened is like in the seismic. Okay, and then we have to transition to the next level. So you have this input, right? So imagine these are 2D. Imagine that's 2D. Okay, but you have this multi-channel, it's like these are your channels. So in natural images, in a picture that you take, when you have the colors, you usually have R, G, B. That's the colors, okay? But imagine that we don't have RGB. We have here, we have the amplitude, and here, we have the coherence, here, we have the aberrancy. So we have attributes in the channels. So that's a multi-channel consideration. So that's one approach. The other approach is like you have multiple inputs. Awareness. And then you can multi-input instead of multi-channel, but I'm going more for the multi-channel in this one. Any other question for AI? AASPI, sorry about the next time with the demos, use just one volume, not two at the same time. But after that, yes, for the 3D, as I said, you have the capability now with seismic faults. There is a horizon example, but you can actually load horizons there. So as I said, more capability for all of you to QC your results and then export to your interpretation package. So any questions?
Great. Thank you, David.